All right, now it's time for us to talk about evaluation of search engines. This is actually one of the biggest topics that we're going to cover in the course. Well, I think one of the things that I want to really mention about it is uh, you might go, oh, why would I ever need to? This is so niche. How to evaluate a search engine? I think the big thing here is um, it's it gives us a perspective on how do you evaluate a complex information system. Yes, it's an information retrieval system, but it's a complex information system. And you're going to have the potential to be part of and build lots of different information systems in your life if you go into software or management engineering or anything like that. So often the determining whether or not that information system uh, improves over an existing system is actually quite a complex thing, because we actually need to be concerned with usually the people who are using it, the tasks they're trying to solve, and are they able to solve their tasks better? Is there actually a net improvement for them through the use of this information system? How well is it actually working? You've seen some of this actually if you have taken MSCI 343, our Human Computer Interaction course. That course is going to give you a perspective on evaluating the user interface. We want better user interfaces than worse ones, I guess. Anyway, nevertheless, evaluation ends up being really critical, and I actually see it applicable to not only software but many other domains. And so this is a a good way to think about things, and especially again, you get into the data science, get into machine learning, you're going to be evaluating how well something is working. And there's not just, I'm measuring the accuracy of one versus the other. There's lots of different ways to measure things. And this mindset of, yes, I'm going to make an algorithmic improvement. I'm going to change my information system. And now I'm going to measure, have I made it better? That's a really big thing. All right. So I want to take a step back though. So the way I usually do this when I have people in person in class and I've got a room filled with management engineers, I pose to them this notion that, you're hired to improve a factory. Okay. What do you do? And the great thing is management engineering students largely are able to formulate a brilliant, excellent answer. It always gives me, when I hear it, it gives me faith in our educational system, our program. It's like, this is great. You've already learned everything that I need to teach you now. Basically, the core ideas you already know. Now, I know that there's some people in this course who are not management engineers, and so I'm going to go through this as well for them. But management engineers, I encourage you, maybe just pause the video for 5 seconds if you can, and think to yourself, how would I do this? Do I actually know the answer to that question? Chances are you know a lot of it already. So what we get when we've done this, I've done this with students, is we basically end up with an answer that gets formulated as follows. And I'm serious. This is from the students. This is not me manipulating them to produce the answer. This is what they come up with. Is first step, they go, all right, I got this factory. Well, I'm going to go in and I need to identify, the systems and the processes in place at that factory. What is it? How is that factory put together? What are the parts? What are the processes at work? How do people do things, and so forth, so on. I need to see what's going on, and then once I have that sort of laid out, I'm gonna get in there and we're gonna start observing, or monitoring, or measuring, and so forth, and start taking data. I need to know how long things take to get from A to B, I need to know rates of defects, all sorts of things. I need to really understand what's happening and how long do things take, and start collecting lots of data. All right, so you're mapping things out, you're going to be measuring, and then they'll talk about, well, it is going to be really important for us to know the KPIs. For those of us who are not up on our 3 acronym lingo, these are knowing the key performance indicators. And so these are the measures that tell us how things are going in the factory. So for example, it could be units produced per time. You could have measures of defect rates, all sorts of various things that tell us what is the status. It's our way of measuring. We've got this system going, but what can we say about it in a quantitative fashion? Beyond, hey, it's looking good. Now, we don't want qualitative, we want quantitative measures. Again, because we want to be able to talk about, did we make an improvement in the system or not? So, and we always have to keep in mind, we have to know what the right KPIs are for that which we want to improve. So you might need to invent a KPI and get it from the data and so forth. It depends on what it is you're trying to improve. That's a really important thing. The measure must fit what you're improving. Or your goal for improvement. It doesn't do you any good to measure defect rate when you're interested in units produced per time. I mean, it might be important to look at both of those measures, but if you're going to try to improve units produced per time defects, I guess maybe fewer rejected parts could be, but that's not like the best measure. So you have to get the right measures. You got to measure the right stuff. All right. Then you move on. I'm gonna leave. I'll just go ahead. It's all off. Then the next step is, all right, well, let's investigate and find out what's wrong. What is this thing that we need to improve and so forth? Question the system. This is a little, but we need to dig in there, and maybe there's something in particular that we can realize. I see something that might be a problem. Now, as I know what I want to improve, what could be holding us back? I see. It could be this part of the factory. I've identified this part of the factory is what we need to. This is my idea. All right, so this is basically leads to idea for how to improve. All right, then students say, well, I'm going to build a simulation for this factory. And the nice thing here is with the simulation, you can try out ideas without basically changing the factory. So yeah, I've simulated the factory. So here's my idea for improving it. Let me change it in the simulation. Let's see if things get better. So that's basically what the students come up with. And then I like to add in some points about the simulation, because this is a really big part of their answer is we're going to basically have the simulation as a key thing. So the great thing is you can validate your simulation. So some of you may not have taken a course in simulation. The non-management engineers, the management engineers have already taken one. So you can validate your simulation. What does it mean to validate? The big thing here is that this is basically given if you have historical inputs, the KPIs you measure from the simulation match the historical KPIs. So we have all this past history. We went in and we observed the factory, and we know that these were the inputs, and this was how what was feeding into the factory. We made all these measurements. All right, then we built our simulation. If we send those inputs into the simulation, do we get the same measurements back out of it? When the simulation is validated, it basically means the system that we built is able to make good predictions about what is actually happening. So we may never have tried certain amounts of inputs or different styles of inputs, and we could then do that in the simulation and have some good faith that the predictions that we get out, because again, it is a prediction, we don't know for sure, it's not the actual system, but we could be predicting would be good numbers. And we could say, oh, if we change this, the performance indicator improves by 10%. Aha, that's pretty cool. So the validation is a really big thing. Likewise, though, if the simulation is really effective, you could actually potentially measure other KPIs off of it as well. But nevertheless, that's the idea there. Then, again, note, I've mentioned it there, but you know, the great thing about simulations is we can experiment and manipulate the simulation as I said, to make new predictions. Once it's validated, we can have quite a bit of faith that we can manipulate and change it in ways that we probably are able to make good predictions. Not predictions, predictions. This is basically, we're going to be modeling a system, and then once we have a model, we make predictions. That's what all of science is. That's the beauty of it is, sure, you're used to models like in physics. All right, so this is how we would estimate the time it would take for a ball to fall from the building to the ground. That's a model because, oh yeah, we ignored wind and friction and this and that. It's a model. It will give us a prediction. That prediction will probably be useful. It's not perfect, but it'll probably be useful. And the model was nice and simple and we can use it. We don't have to go to the building and drop the ball and measure it 10 times to find out how long it actually took once we have the model. And we could then experiment with going to different heights of buildings from the model. We don't actually have to go to buildings of all sorts of different heights to find out how long it'll take to fall to hit the ground. All right, so once you have that type of model, it's validated, you're able to have some belief in your predictions that it's coming out of it. The great thing is now management can make decisions if proposed improvements basically should be adopted. So that, okay, well, you say we're going to do this. How much is it going to cost? How much improvement do I get? How long is it going to take? They can start making decisions based upon the simulation. Now, it's quite possible, by the way, that they might have like a pilot factory. Let's do it on, especially if you're in some field like chemical engineering, let's do a small version of the chemical plant before we go build a big version of the chemical plant. We want to make sure that our predictions of the way things are going to work actually work that way, because they could always change a little bit once reality sets in. That's great. And sort of one of the huge things there again is that the final thing here with the simulation is that we're going to be able, with the simulation, lowers the risk. It would be one thing for you to go in, study the factory, you go, this is the change you should make. I think it's going to work better. You just think that's the improvement. You've got no way to test your prediction or anything. You're just like, try that out. Well, they try it out. It's a disaster. That was really expensive. The simulation, on the other hand, lets you try it out, measure these KPIs if it's validated, and say, yeah, I think it's going to be this much better. That's a huge change. It's just all happening in the computer. It's kind of like, crash testing in the computer as well. You don't have to actually build the thing and smash it up. We get to do it in the computer, and it's much lower cost. And be able to iterate, try out lots of ideas. If you're making real changes to the real system, you can't try out very many ideas, and you try them out at great risk. So, but in a simulation, I can try out lots of things very cheaply, and we can iterate quickly to probably find a much better solution. All right, great. Now, what I have and I would normally do this in class, is I would say, all right, now we're going to watch some Google videos. Well, it doesn't make any sense for me to watch Google videos with you. What it would make sense, now that we're not in person, it makes sense for you to go click some links and watch those videos on your own. So there's in Learn, inside of the Readings folder, you're going to find that there's a thing, Google Videos. And there's a document that's search quality at Google. And it gives a bit of discussion and overview. And then it gives some suggestions for videos that you should watch. And you should watch these, okay? The first one by Dan Russell, watch enough to get a feel for it. And then the next one, the next two basically watch all of it. And then there's this really cool actual view recording of a search quality meeting many years ago. But it's like getting to watch the engineers actually try to decide, should we approve a new feature change to the search engine. That's a really neat video. You don't have to watch much of it. But if it interests you, you could find it really interesting. And then Google recently has come out with this really long, hour-long video. It's a great watch, but it is an hour long. You don't need to watch it. But I've highlighted some key parts of it that talk about some very interesting things about search. We'll touch upon some of them in the course. One of the big ones, again, being the notion of evaluation and quality. I'm having you watch these videos because I want you to actually see that about what we're about to talk about with evaluation is what is done in industry practice. Okay, this is not some academic course thing. Oh, and Google does some mysterious thing. No, Google uses the same principles, the same notions of how do we evaluate search engines as we do in academia. So what's special that you're going to see in the Google video? I think the big thing is that you're going to see at use here the scientific method. All right, I'm going to have a hypothesis about how we could improve the search engine. And so we've got the old search engine, and we have a way to measure its quality. We make the change, and we're able to measure its new quality. But just like the factory, we don't just want to willy-nilly deploy a change out on the web, and next thing you know, we've got headlines, newspapers, we've got users mad, not wanting to use Google anymore. We want to lower the risk. And so we're going to follow the same way that you improve a factory, you improve this information system, this information retrieval system. So it's a scientific method, basically follows the same steps, you know, where they go, and you'll see that they spend time observing people. That's what Dan Russell does. And so we're trying to try to get an understanding about how people use the system. They're going to build models, basically, of the way that people use the system. Then they're going to use those models to predict performance. All right. And they do this offline. Okay. And they use what's called test collection. And they have effectiveness measures that embody these models to make the predictions. So these are estimates of how good things are. And we've got lots of them. These would be what you would call the KPIs, the key performance indicators. Test collection combined with our models is basically, it's like building a simulation. And we can run all of this not with the live search system, but offline. And from there, we'll be able to get some predictions of the quality. When I say performance, I don't mean speed, I mean quality, how good the search engine is from whatever our measure of quality is with our effectiveness. And there's many different ways to measure that. And so, yeah, this is the you know, just to repeat this, is you're going to see, yeah, these steps of simulation. They won't use the term simulation. They will talk about measuring things, and it's effectively a simulation, though. Or they may use the terms evaluation, which is common in information retrieval. They will also talk about, at this stage, doing side-by-side tests. And so you use the test collection to make these predictions. And then when they think they have something good, they'll run the old version and produce the top 10 results, and they'll run the new version and top 10 results. And then they'll send these out to assessors and say, which of these looks better to you? Because they really want to get this next level of feedback from humans actually looking at it without actually sending it out to the live users yet. So this is the first one. This is the low cost one. And once they've done lots of work here, once they think they've got it good, then they'll do some side-by-side tests. They are much more expensive and time consuming to do. But then if they agree that all looks good, then what you do is you do some sort of small rollout where you turn a feature flag on for a small, tiny subset of the population using Google. And as they're doing searches, you monitor how they're doing their searches. Are they coming back? Are they finding things quickly, and so forth? And if it seems like it's working, it seems like it hasn't harmed the users, hopefully you can maybe be able to see that it's actually helped them. And if that's the case, then there's the decision to roll it out to the whole system. All right, and so everyone gets those changes. And so this is a graduated approach to dealing with the risk. We both do things offline. There's no harm ever to the system at this stage. And we get to try out things really fast, try out different ideas, and estimate and predict how well do we think it's actually improved stuff. When it gets good enough, then we go to the side-by-side tests. We don't really seem to have this. Anything from this point on is not common in academia for improvements, except that we will, rather than side-by-side tests, we'll actually do user studies. Basically the equivalent of human-computer interaction usability, but measuring, people's ability to complete tasks, people's ability to learn new material, and so forth and so on. But at its core, this process it is used throughout the industry for how do we improve search engines. We're going to learn the fundamentals. We're going to learn the key measures that people use. That's what we're coming up to next. Take some time, take a look at those Google videos. The idea again is to be like, yeah, what they do, we do as well. Yes, we don't have massive data centers and we're not working over the web and we aren't worth billions and billions of dollars, but the fundamental mechanisms and the measures and our understanding, that's the way Google measures their search quality and their process, and they follow it. And we're going to learn the same thing here in the course next. All right.